All right. So which one could be false? So let's make a continuous function. So I can make one that looks like this. I could make one that looks like this. And however else, okay? So looking at that one, would the first one actually be true according to our theorems that we wrote so far? This one is a mean value theorem. Any theorem that does exist has to be true. And this one say which one has to be false, so we know this one's not. What other theorem do we know? EVT. So we have something called the extreme value theorem, and that tells us there's an absolute minimum and a maximum. This is our EVT. So that does also exist. When given a curve, can you find the antiderivative of that? Could you find the area under the curve? Yes, I can. So that also does exist. So that has to be B. And given those two scenarios, you can look and see which one is going to make it false. Okay? Questions on that one? Good? Let's go on to number 21. Macy, let's read.
The rate at which water flows out of a pipe in gallons per hour is given by a differentiable function R of time of t. The table above shows the rate as measured every 3 hours for a 24-hour period. Is there some time t between 0 and 24 such that R prime, R prime of t equals 0? Justify your answer.
So we need to figure out where is my y value identical, so that now when I do y2 minus y1 has to be 0. Which 2 points do I have? 0 and 24 has both 9.6 and 9.6. So to justify this, we have to go ahead and use our mean value theorem. So let's write out R of 24 minus R of 0 over 24 minus 0. Now let's plug in those values from the table. 9.6 minus 9.6 over 24. And that has to give me what? 0. So I could write on top, yes, by the mean value theorem, R prime of t must be 0 on the interval 0 to 24.